We have our review apps deployed with Kamal. Now, let's automatically create unique URLs for them. Throughout this series, we've set up an automated system to create temporary environments and deploy web applications to them for review purposes, similar to Heroku's review apps functionality. The first step consisted of using Terraform to spin up new servers on the cloud when opening a pull request on GitHub. Then, we set up Kamal to use a new destination for deploying apps to those review environments. In the last video of this series, we finished automating the process of using Kamal to deploy a web application to the new infrastructure. If you haven't watched those yet, check them out if you want to follow along. At this point, we'll have a fully functional instance of our application ready for validation, and it'll become available through the server's IP address. But if your app requires HTTPS connectivity, you'll need a valid domain name before being able to access the app. While we can always set up a domain name manually for these new servers, the purpose of this series is to completely automate the process, and that also includes creating a unique URL for each review app we spin up in our repository. In this video, I'll show you one way to leverage the existing setup we have so far to create new domain names for each new environment spun up by the GitHub Actions workflow. At the beginning of this series, we set up a Terraform script to handle the server provisioning for our application. The Terraform configuration used in this example creates a new server on Hetzner Cloud and configures it with what we need to make it available for deployment using Kamal. Using Terraform makes it easy for our continuous integration service, in this example GitHub Actions, to generate the infrastructure without needing user intervention. Now that we want to set up a domain name for this server, Terraform can help get us set up. One of Terraform's primary strengths is the ability to mix and match different services under one configuration. We've been using Hetzner Cloud to set up new servers, but the TeamYap application used throughout this series uses Cloudflare to manage its DNS records. Fortunately, Cloudflare officially maintains and supports a Terraform provider to use with its service, meaning I can use it in my existing configuration to add a new DNS record for my review apps and set up a unique URL as soon as we deploy the application to a new server. While the rest of this video explains how to generate DNS records on Cloudflare through Terraform, you can use the information shown here with a different provider. There are different Terraform providers for many popular DNS services like AWS for Route 53, DN Simple, or Bunny.net. So you'll likely find one that works for your needs. Let's start by adding the Cloudflare provider in our Terraform script. In the main Terraform block, we see that we already have the Hetzner Cloud provider set up as a required provider. There's also an empty provider block since we're authenticating with our Hetzner Cloud through an environment variable and don't need to specify any additional configuration settings. Check out part 1 of this video series for more details about this setup. We'll want to add the Cloudflare provider as an additional requirement in our script so we can add the latest version inside this required providers block. After the hcloud provider, I'll add the Cloudflare provider, and I'll set the official source, which is called Cloudflare/Cloudflare, and I'll set the latest version of it, which as of this recording is version 5.3.0. We'll also need to add a new provider block in the root of the script to set up the Cloudflare provider and its configuration. Similar to how we configured the Hetzner Cloud provider, we'll also leave the Cloudflare provider block empty. The only configuration setting that we'll need to set up in this example is an API token for authenticating our Cloudflare account. The Cloudflare provider allows us to set different configuration settings via environment variables, such as Cloudflare API token, to set the authentication token. To generate an API token for editing DNS records on Cloudflare, we'll log into our Cloudflare account, and under Manage Account in the sidebar, we'll select Account API Tokens, and then we'll create a new token. Cloudflare has a couple of templates to generate an API token with different scopes, so we don't need to create one from scratch. We can use the Edit Zone DNS template, which conveniently shows up first on this list. This will give you a starting point for the permissions needed for your token. I'll edit the token name here and add the teamyap.app domain name here so I don't mix up my API tokens in the future. We already see that the permissions are set to allow editing DNS zones, so we don't need to touch that. Under zone resources, we'll want to limit the scope of this API token to the zone that we want to edit. So I'll only include the teamyap domain, which is teamyap.app, and I'll leave the remaining options untouched and continue to the summary to make sure everything is set up. After reviewing these changes and making sure that everything is correct, I'll create the token and make sure to save the created token somewhere secure since it's only shown this one time. We'll use this token later when updating the GitHub Actions workflow. With the Cloudflare provider set up and our API token generated, we can begin adding the resource needed to create a new DNS record for our review app server. I'll scroll to the bottom of the Terraform script to begin setting things up here. Before setting up the resource for creating a new DNS record, we'll first need to retrieve the ID of the Cloudflare DNS zone for the root domain to modify. To do that, we can create a data source here called Cloudflare zone and refer to it as teamyap DNS zone to fetch that information and refer to it later. Here we can use different attributes to filter the DNS zones available to us through the API token we generated earlier. The easiest way to get the DNS zone for a specific domain is to use the name attribute here with the value of the root domain. In this example, I'll use my domain name for the teamyap application, which is teamyap.app. Using this data source, I can now create a new Terraform resource called Cloudflare DNS record to create a brand new DNS record in the teamyap.app DNS zone. And I'll call this one review app A record to reflect what it is. Now this resource requires a couple of parameters. First, we'll need the zone ID, which is the identifier of the Cloudflare DNS zone to use for this resource. I'm retrieving this from the data source above, so I can fetch the value with data, followed by the data source name, which is Cloudflare zone. Then the reference name that we gave it, which is teamyap DNS zone. And finally, we can get the zone ID by specifying the zone ID attribute. The next attribute we need is the type of DNS record to set for this new resource. In this case, we'll want to set an A record to map the server's IP address to the domain name we generate. Next, we have TTL, which is the time to live for the new DNS record. Setting the value of 1 in this parameter tells Cloudflare to set the value to auto, which sets a default time to live depending on the record type. For A records, the default time to live is about 4 hours. We don't expect this DNS record to change during its lifetime, so setting the time to live to auto is fine for our purposes. Finally, we need to specify the name for this DNS record. The value set here is the one that we'll use as part of the URL, so it has to be a unique one. I'll set up the domain name dynamically through the GitHub Actions workflow, so I'll use a variable starting with var, and I'll call the variable Cloudflare DNS record name. These are the required parameters for the Cloudflare DNS record resource. Besides these, I'll add 2 optional parameters. First, I'll add the content parameter. For DNS records of the A type like we're doing here, the content is the IP address where this domain name should point to. We're spinning up the server on the same Terraform configuration, meaning that we can easily grab its IP address through its resource reference. The reference is the resource name, which is hcloud server. Then the reference name, which is review app server. And the attribute for the IP address, which is IPv4_address. The other parameter I'll include for this resource is proxied. By default, Cloudflare will set up our DNS record to proxy through their service, which yields benefits like distributed denial of service attack mitigation, hiding your server's IP address, caching, and more. If you use Cloudflare, it's a good idea to keep this proxy on in most cases, but for this example, I want to make our review apps not rely on Cloudflare for SSL connectivity. So I'll turn off this functionality by setting the value to false. Since I'm setting up a new variable in my Terraform configuration, I'll also need to add the definition to the variables.tf file by adding a new variable block here called Cloudflare DNS record name, which is the name of our variable. And I'll set the type to string so it knows what to expect. And I'll also set a default value of an empty string, so we don't need to specify this value when running the teardown workflow, as I'll show later in this video. Let's go back to the Kamal configuration for the review destination created in part 2 of this series. The Kamal proxy configuration already has the host defined through the review app host environment variable, so we don't have to update anything here. However, we do want HTTPS connectivity to our review app using the new domain name, so I'll add the SSL setting and set it to true to let Kamal proxy handle generating the SSL certificate automatically for us. The rest of the configuration for the Kamal destination doesn't require any modifications, so we're good to go with this setup. The last thing we have to do is to update the GitHub Actions workflow to ensure that Terraform has all the information it needs to create the DNS record on Cloudflare for the new review app. First, we'll begin adding a couple of new environment variables to the provision job. I'll add the Cloudflare API token environment variable needed by Terraform to authenticate with Cloudflare. The value for this environment variable is the token generated on Cloudflare that we showed earlier in this video. I already set it up as a secret on the GitHub repository, so I'll refer to it here with the $sign and the curly braces with the value of secrets and the name of the secret, which I called the same Cloudflare API token. We also need to specify the variable for the DNS record generated as part of this workflow. The updates we made earlier for creating the resource on Cloudflare use a Terraform variable, which we can declare starting with tf_var and the name of the variable, which in this case is Cloudflare DNS record name. The value for the DNS record must be unique for every app to prevent domain name clashes that will cause the workflow to fail. For this example, I'll go with something simple. So I'll start it with review and a dash, and I'll use the workflow's pull request number like I did for setting up the server name when spinning it up on Hetzner Cloud. So once again, I'll use the $sign and the curly braces, and I'll get the pull request number by referring to github.event.pullRequest.number. So for example, if the pull request that triggers this workflow is pull request number 123, we'll have a DNS record created using review-123, which is unique for every pull request, and it'll be easier for the team to find. Let's move to the deploy job and update the review app host environment variable that we set previously in this workflow to use the domain name based on the DNS record created in the provision job. I'll remove this existing value here and replace it with review dash as we did before. And once again, I'll get the pull request number using github.event.pullRequest.number. And I'll also add the root domain of .teamyap.app to complete the host name. Now, something I did want to note here is that I'm manually setting the value of the host name here to keep things simple, but ideally you'll want to maintain consistency between the provisioning and deployment jobs. So for example, if I change the value of the DNS record in the provision job, I'll need to make sure to also update this environment variable in the deploy job. And this is really easy to forget, so it would work better if we just pass the DNS information from Terraform as an output from the provision job to the deploy job, so it ensures that we're using the same value. I'm not doing it here to save some time in the video, but in a real-world application, this is something to address. With these changes in place and ensuring that the Cloudflare API token is set as a secret in the repository, we can push these updates to GitHub and open a new pull request. I have a new pull request here containing these changes, and I'll create it to trigger the workflow as we've seen before in this series. The provision job in this workflow will once again spin up a new server on Hetzner Cloud, but as part of the process, it should also create a brand new DNS record in Cloudflare using the pull request number as part of the record's content. Once that's finished and the deploy job runs, Kamal will use the newly configured hostname we set in the environment variable. After Kamal performs the initial setup on the server and has the application up and running, we should be able to access the review app using the URL based on the pull request number. The pull request I just opened is number 14, so I'll go to review-14.teamyap.app, and if everything is working as intended, we should have our review app accessible under its own unique URL. To make sure that we're cleaning things up properly, we'll also need to do a quick update to the teardown workflow by adding the Cloudflare API token and its value from the repository secrets so we can remove the generated DNS record. When we're done with this pull request, either by closing or merging it, GitHub Actions will remove the server from Hetzner Cloud as shown throughout this series. However, thanks to Terraform, it'll also handle removing the DNS record from Cloudflare without any additional modifications to the teardown workflow. This shows one of the benefits of using Terraform to handle our testing infrastructure. Setting up a URL for our review apps simplifies the testing process by providing an easy-to-access location for testers to check out the new changes. This step avoids the need to search for the IP addresses in these dynamically generated servers, helping teams get started with the QA process as quickly as possible. Also, if your team opens multiple pull requests for testing, having a consistent domain name structure will help avoid confusion about which review app is being tested at any given time. We're pretty close to having a fully functional review app workflow, but there's still one issue to address. In part 3 of this series, we set up 2 distinct steps to determine whether to perform the initial Kamal setup step or if we need to run a regular deploy. This process is due to how Kamal separates these 2 steps, and it's a failure point in our existing process since the initial setup can fail and leave the review app in an invalid state. In the next video, we'll explore how to overcome this limitation, so be on the lookout by subscribing to this channel and to watch more videos that help development teams ship their code confidently, from development to testing to deployment. You can also check my website for a written version of this video, along with more in-depth articles covering Rails, testing, DevOps, and other software engineering topics. Thanks for watching, and I'll see you in the next video.